Okay, welcome to the NUPOC video study guide number 36. Let's look at question 11 in the graphing math section of guide 1. And I think this is probably the most interesting problem in this section. Let's go ahead and think about this for a second here. For x values greater than 0, for positive x values, it looks like this curve, x to the x, is just going to grow really fast, if you think about it, right? I mean, 1 to the 1, that's just 1. 2 to the 2, that's just 4. But, 3 to the 3, that's 27. And then 4 to the 4, let's see, that's 16 times 4. Let's see, what would that be? 64 times 4 would be, let's see, 240, and then 6, 256. 256, and then 5 to the 5, that's 125 times 5, and then times 5 again. So it's going to grow really fast. But for negative numbers, it becomes really interesting. And if you're looking at the solution manual and you're following along, you'll see that they draw a dashed line for negative values of x, and they say, note that the graph is discontinuous at points where x is an even negative number. Okay? So there's obviously something funny going on with negative values of x. So first, let's graph what we know, positive values of x. So we know at x equals 0, this is going to be 1. So let's say that we want to really explore this part of the graph. So let's pick this as y equals 1, and let's pick this as x equals 1. Maybe this is x equals 2. All right. So we know at x equals 0, we have 1, because anything to the 0, including 0, is 1. And I know that's also something that disagrees with the solution. If you're following along, they indicate that y equals 0 at x equals 0. Now at x equals 1, we can all agree that that is 1. Right? And so you can sort of draw a curve between these two. We can say, well, we know it's going to start decreasing from here, right? And we know it's going to start increasing back towards 1 here. And so we know at x equals 1/2, well, that's just 1/2 to the 1/2, or 1/2 the square root of 1/2, which is the square, which is 1 over root 2, right? So let's write that out, right? So at x equals 1/2, we have 1/2 to the 1/2, right? Which equals square root 1/2 equals 1 over root 2. So we know at this point x equals 1/2, we're going to have 1 over root 2, which is 0.707. So maybe that's like somewhere right around here. So we're going to kind of come down like this, and then at x equals 2, we know we're way up at 4, which is, I don't know if this is on the graph or not, but probably don't have room to draw that here, but we know it grows very rapidly from there. Now let's just consider a few points here in the negative x direction. So let's say this is like x equals -1, x equals -2, x equals -3, etc. Yeah, maybe we'll have the half marks here, right? So the best way to really analyze this, I think, is to just go to some sort of plotting platform and put this in. And a lot of them are going to give you an error, or they'll only graph this domain here. And the reason is we're going to see as the solution becomes complex as we go to negative values of x. So let's just look at x and y. So let's look at a few points here. So let's look at x equals -1. Okay? So for that, we will have, let's kind of do the arithmetic in this sort of scratch workspace over here, right? So -1 to the -1, well, that's just 1 over -1 to the 1, which is just -1, right? Okay. So let's say this is -1 here, y equals -1, and x equals -1, so we're going to be down here somewhere, right? And let's take a look at minus 2. Okay. Again, this is one of those even negative numbers that the solution talks about being discontinuous. Let's see if that's true around these numbers. So this is going to be what? Negative 2 to the negative 2. Well, that's just 1 over negative 2 squared, right? So that's just 1 over 4, right? So that equals 1/4. So that's going to be, let's see, x equals minus 2, maybe 1/4 is like right here. So we have, let's write 0.25. And if we look at negative 3, well, again, negative 3 to the negative 3, that's just 1 over negative 3 to the third, so negative 3 times negative 3 is 9, times negative 3 is negative 1 over negative 27. So that's pretty small, and it's negative, so it's like right down here. And we know if we go to negative 4, that we're going to get even smaller. We're going to go with, let's just write it out. So this is negative 127. If we go with minus 4 again, that's going to be 1 over minus 4 to the fourth, right? So this is going to equal something like 1 over, I think we said it was like 256. This is going to be really tiny, right? So what's happening is we're oscillating about the axis and sort of dying out. But now let's look what happens when we have non-integer values, right? So let's write this down here. Now let's look at, say, minus 1/2, right? So if we have, draw this out here, if we have minus 1/2 to the minus 1/2, well, that's, we take this and we invert it, right? So this is going to be minus 2 to the 1/2, right? Well, that's the square root of minus 2, so that's I root 2. So how do we plot this here? So you see what I'm saying? This is we've got an imaginary component, so it becomes a complex number. So here at minus 1/2, we have no real component. You know, if this is the real component, we have no real component, but we've got an imaginary component. So what we'll do is we'll just put that on here as a dashed line. So I'll mark those spots as x's. So this is going to be, that's 1.414, so maybe that's down here somewhere, right? That's the imaginary part. And then if we do the same thing, we're going to see at the at non-integer values of negative x, or non-integer negative values of x, we will have an imaginary component. And our imaginary component will be 0 at integer values, at negative integer values of x, and it will be maximized at half minus at negative values of multiples of 1/2, right? So minus 0.5, minus 1.5, minus 2.5, right? And it will also attenuate and die out, right? So we could say that right about at this point here, we're going to have a 0 crossing of the real part. Let's draw the real part first. So what we have is, we come down, we cross 0, we know. And by the way, there's this little artifact here. If we look at, say, it's going to kind of come up first, then go down. And if we look at, say, minus 1/10 to the minus 1/10, we're going to get something like a minus 10 to the 1/10, or the 10th root of minus 10. Now, if you looked at the positive version of this, you get something like 1.2 something or other. So it's actually greater than 1. So for very small values, very small negative values, we will have an imaginary part, but we will also have a real part greater than 1. So we're going to kind of come up briefly, and then we're going to come through 0 at minus 0.5, and then we'll have our peak at minus 1, and then we come up, we go through a 0 at minus 1.5, and then a peak at minus 2, and then 0 minus 2.5. Then we just kind of oscillate and die out like that. And our imaginary part comes along. It's 0 all the way for all positive values of x. And then here we come down to, I'm going to draw it as a dashed line, to a maximum at minus 0.5, right? And then we're going to have another it's going to be a little bit greater than 1/2, right? Which is going to be our value of, would that be minus 3/2, right? So if we looked at that and we said minus 3/2 to the minus 3/2, well, that just equals minus 2/3, right? To the third power square root. So you can see here the reason we don't get any real component at these values of 1/2 is because we have an odd, it's an odd power. It's, 3/2, 5/2, 7/2, so it's an odd power that maintains the negative sign here, and then we got to take a square root of it. So we're going to end up with I, right? It's going to be I times something, it's going to equal I, right? Root 2/3 like that, which is going to equal I, let's see, root 2 to the 3 is 8, I root 8 over root 27. So whatever that is, right? So if we look at it, if you plot it, you're going to see that it's a little bit more than 0.5, I believe. I'm looking at my notes here. So we come down here, and then we head through a 0 at the integer x equals -1, and then we a little bit higher than that, and then we peak up here at minus 3/2, and then we come down through a 0 here at -2, and then peak at minus 5/2, and then 0 here, peak, and we die out. So this is the real part, and this is the imaginary part. Right? So this is one of the more interesting graphs in this section. I really like it. It's pretty cool. You'll notice that the solution we develop here differs a little bit from what they have in the solution manual. But go ahead and check it out. In the solution manual, it's a little bit different. They talk about some sort of discontinuity here and negative integer values of x. I don't think we actually have that. Certainly we don't come down to 0 here like they do in the solution. We come back up to 1. We have this little hump, and then we break out into a complex number where we've got the real component oscillating and attenuating towards negative infinity, and we've got our imaginary component oscillating and attenuating towards negative infinity.